Section 2 of Chapter 1 is going to focus on classifying organisms. As you saw in the last section, that our planet provides a variety of different organisms to observe and look at and enjoy. We're going to be asking questions like why do biologists classify things? How they classify things, what indicates what level of classification each organism is. We're going to look at the relationship between these levels through taxonomic keys, and we are going to look at the relationship between classification and evolution, which will be covered much more in depth later on in the year. We're going to start by looking at what classification is and why we decide to do it. There are over 1 million known organisms on this planet. That's a lot. Classification is going to help with the process of grouping these things based on similarities. So we're going to take all these millions of organisms and we're going to put them into different categories based on similarities that they exhibit. Biologists are going to do so because it's going to make organisms easier to study. Basically, hey, if this guy here has feathers and flies, we can stick him in with birds and he probably does other things similar to birds. This science is called taxonomy, which is the scientific study of how things are classified. And our hero for it is this man, Carolus Linnaeus. Linnaeus was a Swedish naturalist. A naturalist is someone who observes nature. So he's just going to be making observations and recording things, unlike our previous two heroes, Francisco Redi and Louis Pasteur, who actually commenced experiments and hypothesized things, went through all that. Naturalists tend to just study and look at organisms in nature and decide why things happen the way they are and just kind of make observations and conclusions based on those observations. He's going to start by placing organisms in groups based on these observable features, and his naming system that is going to be derived is called binomial nomenclature. I'm sure you've all seen names in binomial nomenclature, but this is our official category that we're going to call, hey, these are the way we name organisms. For example, you see the scientific name, right? Well, that's the binomial nomenclature. Here's the scientific names for 3 common cat-like organisms. They are all animals, so they all have that in common. And they all have the same genus in common too, which is Felis, as you can see. So you have your different classifications and different names, just as examples of binomial nomenclature. The two categories we want to focus on with binomial nomenclature is the genus and the species. The first name, for example, our Felis domesticus, if you remember from the previous slide, was your house cat. The first name in its binomial nomenclature is its genus. So in this case, the house cat's genus is Felis. And you will note that in the previous slide here, all 3 of them fall in the same genus. I know this because the first name of each of them are all Felis. Our second name is the species name. Species is going to refer to organisms that are so similar that they can actually reproduce and create offspring that can also reproduce. And the second name of that will be its species name. So first is genus, second is species. There are some rules to this, just to keep in mind. Only the genus is going to be capitalized. So only the first name gets capitalized. Both names are going to be italicized, and they are going to be using the Latin names for them. This is simply because at the time when Linnaeus made this naming system, all the scientists used Latin